Hello, this is Gary Marr of Arizona State University. This screen capture is for my IFT 101 students. In the screen capture, I wanted to show you some Python examples of some of the topics that we've covered in modules 3 and 4, or more specifically chapters 4, 5, and 6 in Sprinkle. Now the Sprinkle text will spend most of its time on logic models, algorithms, flowcharts, pseudocode, not any time in a programming language. Yet part of this class is Python, so what I hope to do is show you how some of those topics would be implemented in Python. And you're going to have other programming languages you'll take, and they'll be implemented a little bit differently there. But Python's a great language to start off with, and the intent here is to take this logic model and convert it into a working application that can be tested on a computer, and that's what Python is going to facilitate. So, two examples. Mod 4 example and Mod 4 example 2. These will be either put in the module or be put in the Canvas file section. So if you want to grab them, load them in whatever your IDE of choice is, you can. I'm going to use Thony. I think Thony is the best IDE for learning Python. IDLE is fine also, but when we get to debugging sophisticated programs, I think Thony has got some support that doesn't really work as well in IDLE. But there are also other IDEs you can use. You can do Sublime, Atom, Visual Studio Code, PyCharm. There's a number of IDEs that work very well for Python, some of which provide a lot more support than Thony does. But that's kind of a personal decision at that point. So I'm going to go with a blue background, and the syntax coloring here on my screen may be a little bit different than yours because I'm not using the default color scheme from Thony. The dark background seems to work best for these videos, so that's what I'm going to use for my Python examples. So for the first one, I've got some comments on top, which generally just talk to, the name of the program, in general what it does, who wrote it, dates, last update date. And then I've got a section here called variables where I declare my variables that will be global in scope. There's 4 of them, 3 that are numbers, 1 that's text. Python doesn't have really primitive data types. Everything's more or less what's called an object or class object. And it also, because of that, is not a very strict data typing language. So for example, even though I've assigned profit to be a number, and specifically a floating point number because it's a decimal, I could very easily stick text in there. Some languages, if you try to mix and match the data types, will either fail on a compile or give you an error when you try to run it. Python's a little sloppy in this case. It makes it easier to learn how to program in Python, but it's not maybe the best programming language for utilization of computer memory. I guess the thinking is now as computer memory is plentiful and it's cheap. That hasn't always been the case. So that's why we had primitive data types. Python doesn't support primitive data types. So I have 4 variables, 3 that are numbers, 1 that's text or string. I have 1 constant. Constants are not supported in Python, but typically the programming standard for constants is that when you name them, you give them all uppercase letters. So the hope is that if someone else was to look at this code, they would see, first of all, that I've identified it as being a constant. But secondly, since it's all uppercase, it should act like a constant, which means it should not change. This number, 1.5 or half of 1%, should be associated with the name growth rate. Anytime growth rate's being used in a calculation, that's the number that goes with it. In a true sense, this is not necessarily constant will never change. It doesn't change often, which is what we call magic bullets. So for example, if I implement this program, and there might be other programs that use some of this code, with growth rate as being 1.5 of 1%, every time I refer to it, I'll refer to it by its name. If we ever have to change this value, we'll change it just once. That's opposed to having this numeric literal sprinkled throughout my code, used whenever it comes up. And then if it changes, now I'm going to do a whole bunch of either a global find replace or a whole bunch of copy paste, which is not terribly safe when it comes to quality. This is more or less what happens with a Y2K issue. We had too many hard-coded dates and not enough magic bullet numbers. That's what this is supposed to be, also in reference to. I believe that was also discussed in the Sprinkle text. This example here has a module, or what Python calls a function. And the funny thing about that module is it has different names depending on where the function exists. If it exists in a model, flowcharts or pseudocode, it's called a module. But if it's used in an application like this, that isn't necessarily an object-oriented application, one that I've created objects for, it's called a function. That's what Python calls it. But functions which are owned by a class object, and unfortunately this is not a topic we're going to probably get too far into in this class. You'll get into it in much greater detail in your Java class. If a function is owned by a class, it's then called a method. So you use those three, you'll hear those three terms used various ways, and a lot of times they're really used synonymously. But in Python, we're going to call this a function because that's what Python knows it as. There is no class objects I'm going to create for this application. So this function is a function by virtue of the keyword def. Its name is profit calc. It's going to be invoked with two parameters, revenue and expenses. It has another variable called profit within it, which means it's a local variable to this method, because there's also a global variable called profit. And this one's simply going to take and do the calculation and determine profit, and then for whoever called this function, whatever statement, it's going to return back to it the result of that calculation. We'll see that in a minute. Print statement simply puts us at the top of my screen. Here I'm asking for a company name, I'm looking for revenue, I'm looking for expenses. Notice how the text information is not going to be conditioned by another function, whereas the revenue expenses I'm going to cast as integers. Now, if I want them to be decimal numbers, I'll have to use float. Now, some of you in some of the Python you've turned in so far haven't been maybe careful enough in terms of what kind of number you want to use. If you have a floating point number and then using a calculation that is going to output as an integer, it could drop off that decimal, which could cause some problems in terms of the calculation and the way it turns out. It could be wrong. That would be considered a logic error, because as you as the programmer should know what kind of number you want to store. So I'm making it very clear here. The prompt that goes out to the screen for the user is enter revenue as an integer, enter expenses as an integer. I am then going to have a new variable that, well, not a new variable, it's just one initialized as 0 up top here. The global variable, profit. I'm going to call the function called profit calc, and I'm going to give it two pieces of information. Whatever revenue I inputted and whatever expenses I entered on these two statements signed 24 and 25. It's going to take that information, go up to the profit calc function, and insert that into these two local variables, one called rev, one called expenses, for exp, do the calculation and return to me the answer. That returned answer will then be stored inside the variable called profit. On line 30 here, I've got a decision structure, something that was covered as part of the Sprinkle book. And what this is simply going to do is ask me, is profit greater than 1? So whatever value was returned will either be a positive or negative number. If it is a positive number, then I'm going to say congrats. I'm going to take that company name information I captured earlier, embed that or concatenate into this string. So it's going to say congrats, Acme Computing, you are profitable. With a growth rate applied to your profit with our growth rate applied to your profit is projected as, and then it's going to take, again, whoops, let me slide this over some. It's going to take that profit number and multiply it times 1 plus the growth rate. Why 1 plus the growth rate, and why the parentheses? Well, the parentheses means this part of the calculation will be done first, and all this does is add 1 to the growth rate, which is a half of 1.5, 0.015, let's use the decimal value, and it's going to use that to multiply it against the profit, so it's going to give me all of my profit plus a little bit of uplift for the growth rate. That would be printed to the screen, and if it isn't greater than 1, which means it must be negative or 0, then it's going to come up with the answer. Unfortunately, whatever the name of the company is, you are not profitable. I believe that's the end. Yeah, that's the end of the program. So if I want to run this program, what I can do is this. I can come down here and slide my shell window a little bigger if I can find, oh, there it is. I can make that a little bigger. so I can see more of it. I'm going to run this application. There's my print. The company's name is Acme Computing. Okay, I'm going to put $1,000 as its revenue. I'm going to put $500 as its expenses. So therefore, it's going to be profitable, and also it's going to be its growth rate is expected to be 507.4999 repeatable. I did not format the decimal, and hopefully that 0.15 is the correct calculation, because I didn't test this calculation number when I completed the application. I believe it's fine. I'll run this again to get a negative scenario, our negative branch on that if statement. Okay, company name is Acme, and let's say it's got $500 revenue, but $1,000 of expenses. Unfortunately, Acme, you are not profitable. So that's one example that has global variables, a constant. It has the initialization of some variables, initialization of a constant. It has a function. Now with your functions, all language is a little bit different. Some expect the function to be declared before it's called. Sometimes it doesn't care. Python cares. It needs to have forward declaration. So if you're going to have modules or functions, they have to be declared before they're called. This one wasn't called till farther down, so it's in a good spot. This is going to be what amounts to the main processing block, what they might call control in our Sprinkle book. It's going to grab three pieces of information, one which will be string, the first one, the other two which will be integer. They could be float if I want to keep track of dollars and cents. It's going to do a calculation based on calling a function called profit calc and passing it two pieces of information I inputted. These two pieces of information are going to be accepted as local variables. The calculation's done, stored in a variable, then I'll return back to the call point that value that the calculation resulted to. So if it's 1,000 revenue, 500 expenses, I'm going to have 500 sitting here, which I'm going to store in profit. I'm going to check to see if profit's greater than 1. If it is, I'm going to get some congrats and a projection of growth. And if it's not, it's going to come back and tell me that I'm not profitable. So that's the first example. I'm going to come down here, right-click on my shell, and say clear, so I have a clear window. That's all that does. I'm going to click on my second example, Mod 4 Example 2. This one is pretty much the same at the top. What's different is it's got a pre-test while loop. And so what this is going to do is the Boolean expression or conditional expression is going to say, if next company is not equal to Q, then basically perform the three inputs, the calculation, the comparison, and then I've added a new statement at the bottom of the loop, which is going to say for next company, either hit enter or capital Q to quit. Now the way this is blocked off in Python, in fact I should talk about the block up here too. At the end of my function statement there's a colon, okay, required, and then the statements below it have to be indented to the same character position, because those are the statements that really correspond to that code block defined by that function. On the if statement there's also a colon, and this is one code block, and then also the else has a colon, there's a second code block. On the while loop, there's my colon again. This is the code block that's on the while loop, all of those statements. So when it first comes into the while loop, it checks to see what next company's value is. If it's not a Q, then it executes all these statements in blue, reaches the bottom, says hit enter to continue. So that means the next company would have a value of empty, or a value of capital Q to quit. If it's a capital Q, okay, then we must be done processing, the program ends, and that's the end of it. If it's enter, the enter key is hit, or actually anything besides capital Q would work, it'll come through and loop through and ask us all these questions again. So let's run this one, demonstrate it. That one's profitable. We can enter a second one. This one's not profitable. This time you hit a capital Q, and the program will end. Both these programs are examples of how you use sequence structures, decision structures, while loops, global variables, local variables, function calls, functions that accept parameters, functions that return a value, because from the Sprinkle readings, probably what you'll hopefully remember is that these arguments that are on the function call, there could be no arguments, there could be many arguments. They're separated typically by a comma. They become local variables to that particular block of code. And this information will come from the call point. The call point's down below because we have to have forward declaration. This is where it's called. The arguments on this call to the function must equal the parameters in the function. So there's 2 here, 2 here. Revenues first, expenses is second. That's the way it's done up here. Now, if I did this, if I put expenses first and then revenue, this would still work. But is profit calculated by expenses minus revenue? No, that would be a logic error. In other words, the program would work absolutely fine, but it would give me a wrong answer. There'd be no errors from Python saying, hey, I did what you told me to do. If you told me to do it wrong, I did it wrong. And if I reverse this to be expenses and revenue, that would be wrong. If I called it with one argument instead of 2, that would also fail. Or 3 instead of 2, that would also fail. This is true of all programming languages. Well, hopefully this helps. Maybe it'll put in perspective some of the topics covered in Sprinkle and how it would specifically write to the Python programming language. Thank you.